Okay, good evening, Sarthak, Devang, and Raktim. Can you people hear me?
Good evening, sir.
Good evening, sir. Okay, so we can start. Let's start. Last day we were doing PNC. Let us continue. Can you people see my screen?
Yes, sir.
Okay. Okay, this was the last problem we had done. Okay, let us continue from here. 10 different consonants. Okay, there were some more subparts. Okay, there were some more subparts. Okay, without what was it? We need to find out. We need to find out the number of words that can be formed from 3 different consonants and 2 vowels without repetition and begins with a consonant. Okay. So these 2 parts we have done. Okay, there are some more parts. Okay, I'm writing it down over here. Okay. Part 3. Same question. Okay, same question. If each word, if each word has terminal letters as vowels, has terminal letters as vowels.
The can please show the question once.
Yes, everyone copy it down. This was the question. Done?
Yes, sir.
Okay. Next, number 4, part 4. If each word has 3 consonants and 2 vowels, and vowels are not together. Part 5, vowels occupy odd places. Vowels occupy odd places. Solve.
Sir, in three repetition allowed.
No, repetition is not allowed without repetition.
Oh, okay, sir.
Sir, without repetition.
Of course, without repetition. Okay, so Sarthak has given an answer, but
Sir, no,
Sarthak,
sir.
okay, another question I'm writing. Question number one for today. In Morse telegraphy, in Morse telegraphy, there are four arms. There are four arms, and each arm is capable of, and each arm is capable of taking five distinct positions. Five distinct positions, including the position of rest. Including the position of rest. How many different signals can be transmitted? How many different signals can be transmitted? Okay, Sarthak, I have a question. Did you select the vowels?
Yes, sir.
How have you selected the vowels? Cannot understand.
First is 4 and last is 3.
Oh, like that. Actually, I've got a different expression.
Will I send the value?
Send me the value, final value. Raktim, this is the answer of part 3.
Yes, sir.
Okay, checking. Okay, good evening, Shomita. Can you hear me?
Good evening, sir.
Okay, Shomita, I have given this question solve.
Yes, sir.
Okay, Raktim, part 3 is correct. Sarthak, check part 3. Okay, Devank, you are missing something. Yes, Sarthak, part 3 is correct.
Sir, why couldn't I use the first method?
First method. Acha, first method, I don't know what did you do. I have to check. What did you do in the first method? I have to check. Okay, Devang, check your answer again. Raktim, your answer is correct. Okay, let me solve. If each word has terminal letters as vowels, let us start. Terminal letters should be vowels. Okay. So this is part 3. First of all, number of ways to choose. Number of ways to choose 3 consonants and 2 vowels will be how many ways? 10C3 into 4C2. After that, you need to arrange also. Terminal letters should be vowels. Okay. So for terminal letters, how many vowels I have selected? 2 vowels I have selected. And for 3 consonants can place them in 3 positions. Right. So ways to arrange 2 consonants. Sorry. Ways to arrange 2 vowels. 2 vowels will be equal to 2 factorial, and ways to arrange 3 consonants will be equal to 3 factorial. So total arrangement will be 10C3 into 4C2 into 3 factorial into 2 factorial. Okay, Shomita, there is a slight mistake in number 1. Shomita, did you try part 3, part 4, and part 5? These are subparts of the previous question last day which I gave.
Oh, no, sir. I thought the question 1 is the one with the telegraphy.
Oh, acha, acha. No, see, I've solved part 3, you see. First
Yes,
of all,
sir. Yes, sir.
we need to choose the words in such a way such that each word has terminal letters as vowels. Okay, terminal letters should be vowels. So first of all, you have to select 3 consonants and 2 vowels. That can be done in 10C3 into 4C2. Next. So 2 vowels can arrange themselves in 2 terminal positions in 2 factorial ways,
Yes, sir.
and 3 consonants can arrange in 3 remaining
3
positions in 3
factorial ways.
factorial. Is it clear?
Yes, sir.
Okay. Try part 4.
Sir, I've joined.
Okay. Try to solve. Did you understand part 3? Tell me, Naiman.
Sir, I haven't seen the question only.
Okay. See. These are the first three problems are subparts of the previous question. I mean, the last question which we did.
Yes, sir. That answer I have sent.
No, no, these ones I gave it now.
Oh, acha, acha. Okay, okay.
Sir, I've sent part 4.
I'm checking. Okay, Sarthak, I think I've got a different answer. Check it again. I think Devank, your answer is correct. Okay, should I solve part 4? It is
Why?
written. It is very easy. Vowels are not together. What else you want? This one, this kind of problems we have done so many times. Correcting, I have got a different expression. Oh, yes. It is correct. It is correct. Raktim, your answer is correct. Yes, Sarthak, your answer is correct. Okay, I'm solving. If each word has three consonants and two vowels, and vowels are not together. Vowels are not together means how can we do vowels are not together? Tell me. Shwamita, tell me. How can we separate the vowels?
So by gap method.
Yes, gap method. But there is another way. Total minus when they are together. Right, tell
Yes,
me.
sir. Yes, sir.
Okay. So never together. Vowels are not together means vowels are not together means total minus always together. Okay. So what is the total number of ways in which they are together? Total arrangement. Total arrangement will be 10C3 into 4C2 into 5 factorial minus always together will be 10C3 into 4C2. Okay, multiplied by in how many ways they can be always together? Okay, first of all, you have to take both the vowels as a single unit. So multiplied by 4 factorial into 2 factorial. Right, tell me, Shwamita. After this, take common 10C3 into 4C2 common. You'll get 5 factorial minus 4 factorial into 2 factorial. Okay, very simple. Yes, Raktim, number 1 is correct. Okay. Next is vowels occupy odd places. Should I solve, everyone?
Sir, solving one.
Solve quickly. Yes, Sarthak done?
You can start.
Hmm?
Maybe you can start, sir.
Okay, wait. Yes, Devang, question number one is correct. Okay, vowels occupy odd places. Okay, Memel, have you done it? Vowels occupy odd places. So total, how many
Sir,
vowels are
I'm
there?
doing question 1.
How many odd places are there?
3,
Three odd places are there, and how many vowels?
2.
Two vowels. So it's like keeping two books in three shelves, right? So number
Yes.
of ways. Number of ways will be equal to 10C3 into 4C2 multiplied by. First of all, vowels will select their odd places. Okay. So vowels will select their odd places in 3C2 ways. Okay. And then it can be arranged in 2 factorial ways. Okay. Rest, three consonants can arrange themselves in 3 factorial ways. Done.
Sir, why
Is it
2
clear?
factorial?
Two vowels can arrange themselves in 2 factorial ways.
Oh, okay, sir.
Okay. Right. Tell
Okay,
me.
Yes,
sir.
I
For
missed that.
the
I missed the 2
positions also,
factorial part.
Hmm? Yes, tell me. Somebody was saying
yes, sir.
something.
For the positions also, here we are taking CC2.
Yes, because two vowels can arrange themselves in three odd positions. Let us say that this is the first position, third position, and fifth position. In 3C2 ways.
Okay, sir.
Okay. Maybe there is a slight mistake.
You want to show the question?
Sathok, did you understand part 5?
Yes, sir.
Maybe Shomita, did you people understand? Raktim?
Yes,
Yes,
sir.
sir.
Okay. Devang, did you understand?
Yes, sir. Actually, I missed the 2 factorial part.
Okay.
Sir, what is the meaning of including the position of rest?
Including the position of rest means all the arms can be at rest also when the machine is not working. That is the
Okay,
zeroth
sir.
position. Okay, I'm solving number 1.
Sir, the answer I sent, is it correct now?
No, that is not correct.
Okay, sir.
Okay, I'm solving. Okay, Sarthak, check your answer again. Okay, so this is the telegraphy. Okay. And it has how many arms? 4 arms. Each arm is capable of taking how many positions? 5 positions. 0 is the position of rest, okay? Zero is the position of rest. Okay. So see, first arm can take how many positions? How many choices first arm has? Tell me. Sarthak?
4.
4. Can it not take 0th position?
So 5.
5 positions, na? Okay. Second arm has how many positions? How many positions it can take?
5.
5. All have 5 positions. I mean 5 choices. So number of signals that can be transmitted. Number of signals that can be transmitted will be equal to 5 to the power 4. Right, 5 into 5 into 5 into 5. Yes
Yes.
or no? Okay, 5 to the power 4.
-3.
But will there be any signal transmitted if all are at rest? Tell me.
No.
No. So we have to subtract 1. Is it clear?
Okay. Okay.
So number of ways will be equal to 5 to the power 4 minus 1. Okay, you can write it down. No signal will be transmitted. Okay, next question number 2. Question number 2. Find the number of ways in which 5 different books can be distributed among 3 children if each child gets at least one book. Solve. Should I start? Tell me number 2. Everyone? Okay, this is actually number 3.
That's it. Number two.
Yes, Mamel, number 2 is correct. Okay, Devang, check number 2. Okay, Sarthak, check your answer again. Raktim, check your answer again. Sarthak, check your answer again. Okay, let us start. Number 2. We need to find out the number of ways in which 5 different books can be distributed among 3 children if each child gets at least 1 book. Okay. Number of ways in which 5 different books can be distributed among 3 children if each child gets at least 1 book. Okay. So total number of cases. Okay. So Memil, can you tell me how did you get this? Can you tell me your process? Hello, Memil, are you there? Hello. Am I audible to everyone? Devang,
Yes, yes.
Nandit.
Yes, sir.
Memil, can you hear me? Okay, anyways. Total number of ways.
Is the last answer I sent it?
Oh, that is not correct. Okay. Shomita, can you tell me how did you solve?
So first I found out the number of ways where one person gets no book. That is 3 into 2 to the power 5, which gives us 96. And then I found out the way where number of ways all books are received to one children. That is only one child gets all the books. That is in 3 into 1, that is 3 ways. And we have 3 children and 5 books, so I did it total ways is as 3 to the power 5, which gives me 243, and then I subtracted minus 96 and added plus 3.
Why did you subtract 96 and plus 3?
Sir, because we need to
Hmm. Because we need to what?
in the total ways where 5 books are distributed among 3 children, we need to first 3 to the power 5, then the ways with at least one person gets no book that we need to subtract, and then ways where 2% gets the book that we need to add.
Why? You're subtracting, then adding. Why? Cannot understand properly. Okay, pay attention. Total number of ways will be equal to, it can happen that all the child gets on one book, right? I mean, all the child gets all the, I mean, one child gets all the book, right? Tell me everyone. It can happen that one child gets all the book. It can happen that two children gets all, plus required, right? Tell me everyone. It can happen that all the child gets one book. It can happen that two children gets all the book. And it plus required, that is at least one book
But
is given to,
sir, in
huh?
the first case, if one child gets all the books, then how can we distribute at least one book among the other children?
Yes, that is the required case. That is why I wrote required. That is my motive to find out. Right. Total number of cases can be divided into three parts, three cases, right?
Yes,
One
sir.
child gets all, two children gets all. Plus, at least one book is given to all the children, right? That is the
Yes.
required. Now, what is the total number of cases? Tell me. Devang, what is the total number of cases? Total ways to distribute five books to three children.
3 to the power 5.
3 to the power 5. In how many ways? One child gets all the book. First of all, you will select the child. Number of ways to select the child is 3C1, right?
Yes, sir.
Multiplied by 1 to the power 5. Right, tell me, Raktim, Memel,
1 to the power 5.
means giving all the books to one child,
Okay.
right? Plus, two children gets all the book. Means any two children can get all the book, right? So first of all, you'll select the children, 3C2, right? And in how many
Into 2 to the
ways
power
can
5.
we, into 2 to the power 5? But over here, there is a catch. There is a catch in case 2. There is a mistake. Can you identify? Can anyone identify? There is a small mistake I did just now. In the second case, it can happen that you have given all the books to a single child, right or not? Tell me.
Yes.
Right, Devang, Raktim,
Yes, sir.
Yes, sir.
Anandit, can you understand?
Yes, sir.
So I need to subtract those two cases plus required. Now you have to calculate. So required will be equal to 243 minus 3 plus 3C2 is 2 into 3C2 is 3 minus 1. 2 to the power 5 is 32 minus 2, 30. 30 into 3. Okay, this will give us 150. Tell me, is it clear to everyone?
So can you please explain that case 2 children gets all?
First of all, you will select two of the children.
Yes.
Okay. Then you start distributing the books. In how many ways can you distribute 5 books to 2 children?
2 to the power 5.
2 to the power 5. But over here, Sathuk, there is a catch. Can you understand that all the books can be given to a single child in 3C2 into 2 to the power 5 ways?
Yes.
Right. But those cases have already counted over here. Right.
Yes.
Okay, so that's why I subtracted 2 cases. Okay.
Okay. Okay.
Under
Okay.
is it clear?
Yes.
So this will give us 150. Is it clear to others? Anandit, Devank, Raktim,
Yes,
Shomita,
sir.
did you understand this method also?
Yes, sir.
Okay. Try both problem.
Sir, in the row side, all people can row.
Yes, Raktim, you were saying something.
Sir, in the row side, all people can row.
In the row side?
Sir, all people can row.
No, no. 8 can row but cannot steer.
Yes, and three can row, but
But cannot. 3 can steer but cannot row. Understood? 3 can row but cannot steer. Okay.
after that, can you told the question? Explain the question.
See, it's an 8-oared boat. Okay. It is to be manned with a crew of 11 members, of which only 3 can steer. Only 3 people can steer, but they cannot row. 8 can row but cannot steer. Okay.
Yes,
Uh,
sir.
okay. 2 of the men can only row on the bow side, and there are 2 people who can row only on the bow side. They don't have a choice. Okay.
Yes, sir.
So you
And
have to
and
determine
sir,
in how
other places the man can only row.
the other places man can only row. Cannot understand. Other this one I cannot understand. What are you saying?
Sir, I'm saying like two people can.
Oh, the 2 people who are remaining.
No, sir. Sir, I could not understand the question. After that part, how can I select?
Sir,
Out
on
of
the
the
bow side,
wait. Out of the 8 people who can row, only 2 of the there are 2 people who can row only on the bow side. The other 6 people can row anywhere.
Oh,
Understood?
acha. Yes, yes, sir. Or I will consider as a line.
Hmm.
Okay, sir, I understood, sir.
Yes, I thought you were saying something.
sir, on the bow side and row side, on both side people can row and can steer.
On row side, people can row anywhere. I mean, there are four rows on the row side and 4 rows on the bow side. Okay.
Okay.
So should I start, everyone?
One.
So 1 second.
Raktim, check your answer again. What is that 3C2?
Sir, I have to select two from these three.
For what?
So the people can go, but
Out of which 3?
so there is written only three can.
Three can steer but cannot row. They cannot row.
Oh, so one second.
Should I solve, everyone? Pay attention.
Sir, please one.
Mimel, Shomita, are you people solving?
Yes, sir.
So who hasn't given the test yet? Sarthak, you have given it, right?
Yes.
Okay. Anandit has also given it. Anandit, you gave, right?
Yes, sir.
Okay, okay. Now, Raktim, check your answer again. First of all, feel the restriction. It is very important. First of all, feel the restrictions. Should I start? Tell me, everyone. See, first of all, feel the restrictions. Number three. There are 11 people. Three can steer. Eight can row. Okay. And out of the eight people who can row, two can row only on the bow side. Right, Shomita, are you getting? While six can row anywhere.
Yes, sir.
Okay. No, Sarthak, check your answer again. So, Sarthak, pay attention. First of
Yes.
all, what I'm going to do is I'm going to fix the steering wheel. Okay, fix the person on the steering wheel. Acha, in how many ways can you select a person for the steering wheel? Tell me. Number of ways to select the pilot. In how many ways can you do it?
Three.
11 C1.
CC1.
Oh, अच्छा, okay. Yes, yes.
Are you getting? Or Shwamita, check your answer again. Number of ways to select the pilot will be 3C1. Right. And in how many ways can you put the pilot on the steering wheel? Tell me.
3 ways.
What are those three ways? Tell me. There is one pilot. You have to put it on the steering wheel. Tell me. What are those three ways? Hmm? Sarthak?
Okay, sir. One way, one.
One way, na?
Yes.
I thought one way just by putting it on the steering wheel, another way by throwing him on the wheel. Right.
Good.
Okay. Next. Now let us decide for the other people. So there are two people who can row on the bow side. Okay. So you don't need to select. Though there are two dedicated people who can row on the bow side. They can select any two of the row on the bow side. Understood? So first of all, number of ways to put two people on the bow side. This can be done in how many ways? 4C2, right? They'll first of all select the bow, I mean row on the bow side, and after that we
Yes.
can arrange them. We can arrange
Two
them in the
factors.
bow side. So multiply by 2 factorial. Right, Shomita, are you getting? Mimel,
Yes, sir.
Raktim, Anandit, Devank, are you getting?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Next. Now how many people are left? I have substituted, I have put two people on the bow side and I have put one on the steering wheel. How many people are left? Tell me.
8.
Eight people are left. The two
Out
people
of the
who
11, right?
no, the two people who cannot steer, I mean who cannot row, we don't need to think about them, na? They will just sit on the deck. We don't need to
6.
think. Six people are left. Six people can arrange themselves in remaining six places in how many ways? 6 factorial. Arrangement of the remaining people. They have no restriction. Arrangement of remaining people will be equal to 6 factorial. So number of ways will be equal to 3C1 into 1 factorial multiplied by 4C2 into 2 factorial multiplied by 6 factorial. Is it clear, Raktim? Devank, Anandit, Shwamita, Sarthak? Is it clear?
Yes,
Yes.
sir.
Okay. See, the thing is you have to you have to start with the restriction. Whenever you get this kind of questions where there are too many restrictions, always start with the restrictions. Okay. Like see, I started with the steering wheel. Okay. I could have started with the bow side restriction also. Okay. There was restriction on these two people. I could have started with over here also. Okay. Understood. Next, let us do another one. Okay, this is question number 4. Okay, it has five subparts. Solve. It's question number 4.
Sir, from how many boys or girls?
There are four boys and four girls, na?
Uh, they has to be selected, but from how many boys or girls?
No, they have to be seated in a line.
Oh, yes, sir, now I understand.
Okay. Sarthak, why did you add? I mean, no. Sarthak, check your answer again. So should I start the
So
first
just to be
one?
seated.
Yes, not selected. They have to be seated in a line. What does
So
this line
one
means? Selected in a line cannot understand.
is
Should I start? Tell me.
Sir, sending.
so
Yes. Sarthak cannot really understand what are you trying to do in part one. Sarthak, can you explain? Raktim, your answer is correct. Sarthak, can you explain?
that is what I'm thinking. What will I do?
Tell me.
We have to apply permutation, right?
Hmm?
Like here we have to apply permutation, not combination.
Permutation, permutation only, but what does 8p4 means, you know?
Or from
Yes. Anandit, your answer is correct.
so one is sending.
Okay. Sarthak, your answer is correct now. Shramita, why are you arranging boys and girls separately? Is there any restriction?
Sir, can I send all together at once?
Send. Shramita.
No, sir.
Means boys and girls can arrange among themselves also, no problem. Okay. See, it's like you're arranging
Okay, sir.
boys separately, girls separately. Sarthak, check your answer again. Anandit, part 2 is correct. Part 2 and part 3, Raktim, where have you done? You have done it, part 2 and part 3?
Yes, I send a photo of this.
Okay. Now check number part 2. Okay, I got only part 2. Where is part 3?
Sir, I got same answer.
Oh, no, no, no. Check it again. Part 4. Part 4 may be correct. Let's see. No, check part 4 also. Devang, part 1 is correct. Part 2 is correct. Okay. Sarthak, part 4 is correct. Okay, Shwamita, should I solve part 1?
Sir, in part 1, my answer was wrong.
Yes, you have arranged girls and boys separately. Why?
So for part 1, I wrote 8 factorial.
Oh, wait, let me see. That means I have made a mistake while add. Hmm. Oh, yes, part 1 is correct. Actually, that is the answer of part 2 you wrote. Then it is correct.
Yes, sir.
Yes, Anandit, 2 is correct. Sorry, Raktim, part 2 is correct. Okay, Anandit, I'm checking part 2. Part 3. Anandit, check part 3. Sarthak, check part 2. Okay, part 1, everyone got 8 factorial, right? Part 1, everyone got 8 factorial. Part 2. Shwamita, part 4 is correct. Shwamita, part
So
3 is
part
also
3.
correct. Okay. So part 2 I'm solving. No two girls are together. That means we have to put the girls in the gaps, right? So first of all, remove all the girls. Okay, arrange boys. Arrangement of boys can be done in how many ways? Tell me, Sarthak.
4 factorial.
4 factorial. Okay, arrangement of boys can be done in 4 factorial ways. Now 4 boys will give how many gaps? Tell me. Number,
4,
number of gaps will be 4,
5.
5. Okay. And in how many ways can you arrange girls in these 5 gaps?
5 people.
5C4 is to select the gaps, no?
5 people.
Huh? Five C4 into 4 factorial. So total number of ways will be equal to 4 factorial multiplied by 5C4 into 4 factorial. Done. Is it clear, Sarthak?
Okay.
Sarthak, try out part 3. Ratim, check part 3. Devang, part 3 is correct. Okay, I'm solving part 3. At least one girl is separated from the rest. Okay. At least one girl is separated from the rest. Okay. This is part 3. So part 3, can I write it as total minus all girls together? Tell me. At least one girl is separated. At least one girl is separated will be equal to total minus always together. Tell me, in how many ways can all the girls be always together? Tell me. Sarthak, in how many
So
ways?
5 factorial 4. 5 factorial into 4 factorial.
So total is 8 factorial. Total ways to arrange is 8 factorial. From 8 factorial, we need to subtract 5 factorial into 4 factorial. Is it clear? Tell me.
Yes.
Okay, solve part 4. Rectim part 4 is correct. Okay, I'm solving part 4. In part 4, it is written boys and girls are alternate. Boys and girls are alternate, so there are 2 cases. It can happen girl, boy, girl, boy, girl, boy, girl, boy. Okay, let me see. I think everyone has solved it or what? Let's see. Yes, everyone has solved it. Oh, only Anandit. Anandit, should I solve? Tell me, what happened? Yes, Anandit, right answer. And there can be
Plus
another
and
case.
kid right now.
Correct, correct, correct. Another case can be boy, girl, boy, girl, boy, girl, boy, girl. Okay. So number of ways will be equal to 4 factorial into 4 factorial. multiplied by 2. That will give us how much? 1152. Is it clear? Okay, part 5 I am solving. Okay, Raktim, I have got a different expression, but I'm solving part 5. It is written, a particular boy and girl are together while arrangement is alternate. Okay. So first of all, you remove that boy and girl. Okay. Let us say that the boy and girl is P1, G1. You remove that boy and girl, and other people can arrange themselves in boy, girl, boy, girl, boy, girl, or girl, boy, girl, boy, girl, boy. Okay. Let us remove that B1, G1. Acha, first of all, tell me, what is the number of ways to arrange 3 boys and 3 girls alternately? Number of ways.
2 into 3 supplementary.
3 factorial into 3 factorial into 2.
Exactly. Number of ways to arrange 3 boys and 3 girls alternately will be. Right, Shamita, Devang, are you people getting?
Yes, sir.
Okay, next. Now, we need to start, we need to find a place for B1, G1. See, B1, G1, can B1, G1 be over here like this? Tell me. Can B1, G1 be over here like this before B? Tell me.
Yes.
Can B1, G1 be between B and G? Tell me.
No.
This is not possible, right? Tell me, everyone.
Yes, sir.
This is not possible. If they want to be between B and G, they will have to be, they will have to be, they will have to interchange their position, G1, B1, right? Are you people getting? So first of
Yes.
all, let us identify the number of gaps. What is the number of gaps created by these 6 boys and girls?
Okay.
Number of 7 ways, 7 gaps. In these 7 gaps, they will choose any one gap, right? Number of ways to select one gap for P1, G1. This will be 7C1 ways. Okay. Now, in how many ways can B1, G1 be placed in those gaps? Tell me. Only one way, right? Basically, if it is placed over here, then it will be B1, G1. If it is placed over here, then it will be G1, B1. Right? So, total number of ways. So, total number of ways will be equal to 3 factorial into 3 factorial into 2 into 7C1 into 1. Tell me, are you people getting? Raktim, Anandit, Devang, Shomita, Sarthok.
G1
Yes.
cannot be placed between G and B.
Sarthok cannot hear you properly. Hmm?
So G1 B1 cannot be placed between G and B.
Yes, what I am saying is this particular point, particular girl can occupy a place between G and B. Okay, but there is only one way to keep them, right?
Yes.
Means you cannot put G1 B1 over here, but you can put B1 G1. Means if they are if they are if they are finding a place between G and B, they have to be placed as B1 G1. But if they are finding a place between B and G, they have to be placed in the form of G1 B1. Okay, then only the arrangement will be alternate. Right, is it clear? Tell me.
Yes.
Okay. Shamita, have you understood properly?
Yes, sir.
Okay. Next, part 6. Number of ways in which a particular boy, in which a particular boy and a girl. Raktim, did you understand the previous one?
Yes, sir.
And a girl are never adjacent to each other. Solve. Are never adjacent to each other.
In alternate or without alternate?
Without alternate. Solve quickly. Yes, Raktim, your answer is correct. Okay, Sarthak, I'm thinking, wait.
One is only one.
Ah, yes, you have made a slight mistake. Got it. Yes, Sarthak, right answer. Okay, Shomita, Devang, Anandit, I'm solving. Pay attention. So over here, in how many ways can a particular boy and a girl be always together? Tell me. Number of ways they can always be together. Will be what? Tell me. 7 factorial to 2 factorial? So never together will be? Will be total minus always together. Yes, Anandit, right answer. Always together. What is the total? Total is 8 factorial minus 7 factorial into 2 factorial. Okay. Next. Our next topic is formation of groups. Formation of groups. How groups can be formed. Pay attention. Every selection. Okay, whenever you are selecting, every selection has a corresponding rejection. Has a corresponding rejection. Resulting in the formation of two groups. Resulting in the formation of two groups or teams or selection. Or selection. Okay. So I'll give you some example. Suppose there are, okay, suppose there are three people A, B, and C. For example, suppose there are three people A, B, and C. Okay, suppose there are three people A, B, and C. The number of ways to form a team. What is the number of ways to form a team? Tell me. Of two? Number of ways to form a team of two. Can anyone tell me? Can anyone tell me in how many ways can we form a team of two?
Sir, 3C2.
Will be 3C2? Right. Shomita, are you getting? Tell me.
Yes, sir.
Devank, Sarthak, Anandit,
Yes.
are people
Yes.
getting? Okay. So let us see what are the selected teams and what are the rejected teams. Okay. In the first column, I am going to write down the selected teams. Okay. So what are the, let us say you are selecting A and B. Whom are you rejecting? Whom are you rejecting? Tell me. Hello. In the first case, whom are you rejecting? There
C.
is C. In the second case, whom are you rejecting?
A.
A. And the last one, B. Okay. So what we can conclude? Thus, we can conclude that number of teams formed. We can conclude that number of teams formed, number of teams formed by selection will be equal to 2. Okay, number of teams that you can form by selection will be equal to 2. Okay, in every selection. Hence, the number of ways to form two groups, one containing one element and the other containing two elements, and the other containing two elements will be equal to 3C2. One containing one element and the other containing two elements will be equal to 3C2. Okay. Next, let us take another example. What is the number of ways to form two teams? Two teams containing two players. Two teams containing two players out of A, B, C, and D. Okay. In how many ways can you form it? Tell me. Tell me, everyone. In how many ways can you form two teams containing two players out of A, B, C, and D? Anyone tell me? Hmm? In how many ways can you form two teams containing two players out of A, B, C, and D? Anyone tell me quickly? Hmm? Sarthak, Anandit, Devank, Raktim, tell me. Anyone? Hello. Am I audible?
Yes, sir.
You have to form two teams containing two players out of A, B, C, and D. How many ways can you form a team of two out of two players? Tell me.
Force.
What? Sarthak, why so slow? Acha, Devank, you tell me. In how many ways can you form a team of two out of four players A, B, C, and D? Tell me.
4C2.
4C2, right? So why were you not saying, Devank? What happened? Not confident? Hmm? Okay, let us.
So I just force it only.
But so low, couldn't hear you properly.
Sorry, wasn't confident.
Okay. In the first column, I'm going to write down selected team. Second column, rejected. Same thing, selected. And then rejected. Okay. Maybe you have selected A and B. Whom are you rejecting? Tell me. You are selecting A and B. Whom are you rejecting?
C
Hmm?
and D.
C and D. Next. If you are selecting A and C, whom are you rejecting? Whom are you rejecting? Tell me. Hmm?
B and D.
B and D. Next. It can happen that you are selected. It can happen that you are selected A and D. Whom are you rejecting? B and C? Next. It can happen that you are selected. Tell me another type of selection, another team which you have formed in 4 to 2 ways. Tell me.
B and C.
B and C. Whom are you rejecting?
A and D.
A and D. Next, another way. Tell me. Another way.
B and D.
B and D. And you are rejecting A and C. Lastly, you have selected C and D and you have rejected A and B. Right, tell me. Is it clear? Raktim, Devang, Anandit. Anandit, is it clear?
Yes, sir.
Shwamita and
Yes, sir.
Sarthak, is it clear?
Yes, sir.
Okay. These are the teams you have formed and the teams you have rejected. But can you people notice? Can you people notice? The first way of selecting is same as the last way of selecting. Can you people see? Tell me. See? The first way of selecting and the last way of selecting is same. Whether you form a team of AB and CD, okay, or CD or AB, they both are same, right? You are basically partitioning the set. Okay. Right, tell me. Raktim, Anandit, same team. Okay. Similarly, ACBD and BDAC, they are same. Right, tell me. Sarthak, yes or no?
Yes.
Okay. So basically, by mistake, while forming the groups of equal strength, okay, here we can see that, here we can see that by mistake, by mistake, we gave importance to the order. To order. Okay, by mistake, we gave importance to order. Okay, so that's why we need to divide by 2 factorial. Okay, so the number of groups, number of ways to form groups. To form a group of two and two will be equal to 4 factorial, actually 4C2 by 2 factorial. Remember, you can simplify 4C2 by 2 factorial. This can be written as 4 factorial divided by 2 factorial into 2 factorial multiplied by 1 by 2 factorial. Okay, it signifies that there are two teams of equal strength, so we have to divide it by 2 factorial. Okay, next. Okay, let us extend this particular form to more than 2 sets. Suppose we need to form three teams of 2 players each. 3 teams of 2 players each. Okay. So the number of ways. What will be the number of ways? Now we have to select 3 teams of 2 players each. Okay. So what is the total number of players there? Tell me, everyone, what is the number of ways of forming three teams or two players each? Tell me. Total, how many players are there? Six. So first of all, you will select two players, 62. Right.
By factorial.
Not yet, not yet, not yet. You have selected two players for team one. Next, we need to select players for team two also, right? How many players are remaining? Raktim, tell me.
Sir, 4 player.
Yes, absolutely correct. Four players. Out of those four players, we need to select how many?
Sir, 2 and 4C2.
Again, 4C2. Right, Shomita, did you understand? Yes or no?
Yes, sir.
Okay. Multiplied by 2C2 means they are already selected in the third team. Okay. Next. Now, over here, I'll make one observation. Okay. So let us say that the players are, suppose the players are, suppose the players are A, B, C, D, E, and F. Okay. So I'm forming three teams. Okay. I'm forming three teams. Okay. Taking this six players into consideration. So team one. Okay, team two. And lastly, team three. Okay, in team one, let us say you have selected A and B. In team two, you have selected C and D. In team three, you have selected E and F. Okay, it can happen that you have selected A and B in the first team, E and F in the second team, and C and D in the third team. Are you people able to understand? Tell me. Tell me, Devang, Raktim,
Yes, sir.
Yes, sir.
Anandit, Sarthak, and Shomita. Did you people understand?
Yes, sir.
Yes, sir.
Yes.
Okay, next. But there will be some more cases. Okay, it can happen that you are keeping C and D in the first team. Next, with CD, you have kept AB in the second team and EF in the third team. Okay, next, with CD in the first place, you can take EF in the second place and AB in the first place. Okay. Okay, it can happen that you have kept E and F in the first team, AB in the second, and CD in the third team. Okay. Lastly, you can keep EF in the first team, CD in the second team, and AB in the third team. Right, tell me, are you people getting? Tell me, Devang, Sarthak, Anandit,
Yes.
Nini, and Shomita. Is
Yes,
it
sir.
clear? Okay. Are you people able to understand that these six ways of forming the teams are same? Tell me, are you
Yes,
people
sir.
able to visualize? So again, what did we do? By mistake, we gave importance to order. Right. Again, we have done the same thing. Again, we gave importance. We gave importance to order by mistake. By mistake. Okay. So number of ways to form groups. Okay, so number of ways will be equal to 6C2 into 4C2 into 2C2 divided by 3 factorial. Okay, let us simplify this. This will become 6 factorial. 6 factorial divided by 2 factorial. Sorry. Divided by 2 factorial into 4 factorial. Multiplied by 4 factorial divided by 2 factorial into 2 factorial multiplied by 1. And the whole thing should be divided by 3 factorial. Remember. Okay. Whole thing should be divided by 3 factorial. Okay. So you people tell me. Wait, let us simplify. 4 factorial gets cancelled. What are we getting? 6 factorial divided by 2 factorial into 2 factorial into 2 factorial multiplied by 1 by 3 factorial. Okay, you can analyze this like this. Okay. You can analyze formation of groups like this. Okay. Next. Okay, so somebody tell me this one. Raise your hand. What is the number of ways? What is the number of ways of forming two groups? Number of ways of forming two groups. One containing 3 elements. One containing 3 elements. Each. Tell me, anyone? Find the number of ways of forming two groups.
So 63 into 3C2 by 2 factorial.
How much? 60? 3
3 into 3C2
into 3C3 divided by
factorial.
2 factorial. Correct. Right? Shomita, did you understand or should I explain? When you simplify this will become 6 factorial divided by 3 factorial into 3 factorial multiplied by 1 by 2 factorial. Hello. Anandit, Devang, Shomita, did you people understand? Tell me.
Yes, sir.
Yes, sir.
Okay, so this one, Shomita, you tell me. Okay? Number of ways. Number of ways to form 4 groups. Two of them containing 3 elements. Containing 3 elements. and two of them containing and two of them okay. Wait a minute. Number of ways to form four groups, two of them containing three elements, and two of them containing two elements. Containing two elements. Okay, tell me, Shomita, in how many ways you can form
Yes, sir. One.
four groups, two of them containing three elements, and two of them containing two elements? Tell me. Why is it taking so long?
Sir, we need
Tell me.
to form four groups. So two.
Tell me, Shomita. Total, how many players are there? Tell me. Total, how many elements are there? Shomita, total, how many
So
players are?
four groups need.
Four groups are there, but total, how many players are there? How will you know?
So five.
Five players are there. Five elements are there. Tell me.
Sir, can I try?
Wait, Shomita, how did you say five? Tell me. What was the reason behind it? I want to know.
Four groups. So 10.
10 elements are there, na? So now tell me. This will be equal to 10
Yes,
factorial divided by.
yes, sir, because 2 has 3 and 2 has.
Hmm. So 10 factorial divided by
Yes, sir. 10 factorial into 2 factorial
3 factorial into 3 factorial into 2 factorial into 2
into
factorial.
into
Right.
2.
Then
Yes, sir.
there are two groups
Into
alike of one kind. So 1 by 2 factorial,
1 by 2 factorial into 1 by 2 factorial.
2 factorial. Correct. Tell me, is it clear to others? Devang, Sarthak,
Yes, sir.
Anandit,
Yes, sir.
Raktim?
Yes, sir.
Okay. So one last problem for today. Okay. Based on groups. Shamta, you have understood, right? If you have not understood, you can tell me. Tell me.
Yes, sir.
Okay, one last problem. Okay, do it carefully, everyone. Question number 5. Find the number of ways. Find the number of ways in which 30 soldiers, in which 30 soldiers 30 soldiers can be deployed equally on 3 border posts. And this is the last problem, everyone. Quickly solve. Okay, I hope everyone has understood how to solve, how to form groups.
So have you got the answer?
Okay, Sarthak, check your answer again. I think there was a slight mistake. Okay, Shomita, should I start? Tell me. Is it
Just
done?
sending.
Send, send. Others also send. Okay, let me see. Is Shomita right answer? Ajay, tell me, what is the number of ways to form groups?
So, sir, one
Number of ways to form groups will be what? Tell me.
Sir, I've got an answer.
You've got an answer. Send. Let me see. Sarthak, this is the number of ways to form groups. After that, you have to deploy them on the border post, right? On 3 border posts.
okay,
This is just a way to form groups which you have done. Devang, your answer is correct. So number of ways to form groups will be equal to, yes, Anandit, right answer. Sarthak, yes, it is correct, Sarthak. So only Raktim and Shomita is left. Should I solve Raktim and Shomita?
Sir, I had sent the answer.
Okay, Shomita is correct. Raktim, should I solve?
And
Again, you have sent.
yes.
But this is just the way to form groups. So, Raktim, number of ways to form groups will be 30 factorial divided by 10 factorial whole cube multiplied by 1 by 3 factorial, right?
Yes, sir.
So, Raktim, let us say you have formed 3 groups, A, B, and C. So, these 3 groups can arrange themselves in 3 border posts will be how much?
Factorial.
Yes. So, number of ways to arrange them. Number of ways to arrange them into 3 border posts will be equal to 30 factorial divided by 10 factorial whole cube into 1 by 3 factorial into 3 factorial. This 2 gets cancelled. This will be equal to 30 factorial divided by 10 factorial whole cube. Tell me, everyone has done it like this, right? Devang, Sarthak, Anandit, like this only, right?
Yes,
Yes, sir.
Okay. And Shamita, you have done it like this only, right?
Yes, sir.
Raktim, is it clear?
Yes, sir.
Okay. Okay, so I think everyone, we can keep it till now. Next class, that is upcoming Monday, we'll again continue. Okay. Next class, we'll do some more problems on formation of groups. Okay, thank you everyone, and good night. I'll send everything in WhatsApp.
Thank you, sir.
And good
Thank you,
night,
sir.
everyone. Okay.
thank you, sir.